Question 1. From the perspective of safety protocol enforcement, what should Ms. Gomez do when she notices a coworker using a brazing torch adjacent to an open solvent storage area without a fire extinguisher nearby? A. Immediately report the violation to OSHA before confronting the coworker. B. Continue her task but remind the coworker later to use a fire extinguisher. C. Stop the coworker, isolate the heat source, and ensure fire suppression equipment is in place before brazing continues. D. Move the solvent containers herself to avoid interruption of the brazing operation. Answer. Correct answer. C. Explanation. Ms. Gomez must take immediate action due to the extreme fire risk posed by open flames near volatile solvents. OSHA Standard 29 CFR 1910.252A 2 Omenthor B requires suitable fire extinguishing equipment to be immediately available in the work area. Continuing work or delaying intervention violates safety protocol. Moving the containers herself without controlling the ignition source is hazardous. Reporting the incident is necessary but secondary to removing the immediate threat. This question tests understanding of fire risk mitigation and regulatory compliance. Question 2. By evaluating the function of capillary action during brazing, what is the primary factor that allows filler metal to successfully flow into the joint gap? A. The gravity acting on the molten filler pulling it downward. B. The viscosity of the flux attracting the filler metal into the joint. C. The tight joint clearance and surface tension drawing the filler metal via capillary attraction. D. The pressure applied by the torch flame pushing the molten filler metal. Answer. Correct answer. C. Explanation. Capillary action, governed by surface tension and adhesion forces, draws molten filler into narrow, well-fitted joint clearances without relying on gravity or external pressure. This principle is central to successful brazing, especially in horizontal and vertical joints. Improper joint spacing reduces capillary effect, causing weak joints or a complete fill. Orr's Brazing Handbook explains optimal joint clearance is typically 0.002, 0.5 inches. Gravity and flame pressure are not mechanisms in capillary-driven flow. Question 3. To illustrate this point, consider is already assigned to perform brazing inside a mechanical crawl space beneath their commercial HVAC system. The space has one hatch minimal airflow and contains refrigerant lines. What OSHA-mandated procedure must be completed before work begins? A. Set up a pourable fan to circulate air into the space during brazing. B. Ensure the area is ventilated by natural convection before entering. C. Perform atmospheric testing and implement confined space entry protocol. D. Use a respirator and enter the space with a fire watch only. Answer. Correct answer. C. Explanation. OSHA Standard 29 CFR 1910.146 governs confined space entry, requiring atmospheric testing for oxygen, flammable gases, and toxic vapors before entry. Brazing introduces combustion gases and heat, increasing risk. A fan or respirator alone does not fulfill requirements. Entry must include a confined space permit, trained personnel, and continuous monitoring. Refrigerant lines pose additional risk due to potential displacement of oxygen. This scenario demonstrates the necessity of procedural compliance in confined environments. Question 4. When evaluating the merits of torch positioning during brazing, what is the most effective way to ensure uniform heating across a joint between copper and brass tubing? A. Focus the torch flame directly on the filler rod to promote rapid melting. B. Heat both base metals evenly by moving the flame in a circular motion around the joint. C. Preheat only the thicker metal before introducing the filler metal. D. Apply the flame to the joint center to quickly raise the temperature. Answer. Correct answer. B. Explanation. Uniform heating is essential to ensure consistent capillary flow and metallurgical bonding. Brass and copper have different thermal conductivities, so the flame must move in a controlled circular pattern, gradually heating both metals. Orr's 2.2 meters outlines best practices for uniform heating to prevent localized overheating and oxidation. Preheating just one metal can cause poor bonding. Heating the filler directly inhibits capillary action and results in a cold joint. Joint temperature, not filler, must initiate flow. Question 5. Under the assumption that a technician is transporting acetylene and oxygen cylinders through A multi-story construction site elevator, which action would be considered both unsafe and in violation of handling standards. A. Securing cylinders upright and riding the elevator with them. B. Releasing excess pressure from the regulators before transport. C. Using cylinder caps and transporting cylinders upright via lift. D. Using a separate elevator without personnel for cylinder transport. Answer. Correct answer. A. Explanation. Transporting flammable gases in an elevator with personnel is strictly prohibited due to explosion risk. NFPA 55 and EGAP1 standards recommend cylinders be transported in upright positions with caps and on freight elevators with no passengers. Releasing excess pressure and securing the cylinders is correct, but riding the elevator with them is a major violation. Acetylene cylinders must remain vertical due to their acetone content, and safety requires isolation from personnel during movement. Question 6. While examining the discoloration around a brazed joint on a steel fitting, what does this typically indicate regarding heat control during the brazing process? A. Insufficient heating that prevented proper filler flow. B. Proper heat application and joint bonding. C. Overheating that altered metal microstructure and potentially weakened the base metal. D. Ideal heat concentration limited to filler metal contact points. Answer. Correct answer. C. Explanation. Discoloration, especially dark blue, grey, or burnt areas on steel indicates excessive heat which can compromise the metal's integrity. Overheating may cause grain growth or carbide precipitation affecting mechanical properties. Or C. 0.3 meters cautions against excessive localized heat on ferrous metals. Ideal brazing heats just enough to allow filler flow without altering base metal structure. Controlled heating minimizes oxide formation and post-braze cleanup. Students must understand thermal limits, not just melting points. Question 7. The fundamental question is, what is the best technique for Mr. Delaney to ensure a reliable braze when accessing a refrigerant-lined joint inside a tight wall chase with limited torch maneuverability? A. Use excessive flux to compensate for restricted heat control. B. Apply filler metal only to the exposed side of the joint. C. Utilize a mirror and low-profile tip to ensure even heating around the joint. D. Increase flame intensity to reach hidden parts quickly. Answer. Correct answer. C. Explanation. Restricted access brazing requires precise control and visibility. A mirror aids visual inspection, and a low profile or angled tip enables even heating, ensuring capillary action throughout the joint. Was B.2 recommends indirect tools and visual aids for inaccessible joints. Applying filler to only one side risks incomplete penetration. Excessive flux can result in entrapment or voids. Heat intensity must be moderated to avoid overheating when space is confined. Question 8. With the advent of oxygen-sensitive refrigerants, why is nitrogen purging considered essential during brazing of copper refrigerant lines? A. It speeds up filler metal flow by creating a pressurized atmosphere. B. It prevents oxidation inside the pipe and maintains refrigerant system cleanliness. C. It acts as a coolant to reduce joint temperature during brazing. D. It replaces the need for flux in horizontal joints. Answer. Correct answer. B. Explanation. Nitrogen purging displaces oxygen inside the pipe, preventing oxidation, which leads to scale and contamination inside HVACR systems. Scale causes flow restrictions, clogging ESES, and compressor damage. ASHRAE Standard 15 and ASAES guidelines highlight the necessity of nitrogen purging in all brazing involving closed refrigerant systems. It does not influence filler flow speed, nor does it serve as a coolant or flux replacement. Students must grasp both cleanliness and longevity implications of oxidation. Question 9. Contrary to popular belief, which factor is least important when selecting a brazing filler metal for copper to steel joints in refrigeration piping? A. Compatibility of melting temperature with base metals. B. Mechanical strength after solidification. C. Color match between filler and base metals. D. Corrosion resistance in refrigerant environment. Answer. Correct answer. C. Explanation. Color match is rarely relevant in HVACR brazing where mechanical integrity and corrosion resistance are paramount. AUSA 0.8 specifies filler metals based on alloy compatibility, strength, and service environment, Not aesthetics. Copper to steel brazing typically requires silver phosphorus alloys or similar with adequate strength and suitable melting ranges. While appearance may matter in artistic or decorative brazing, it is functionally irrelevant in sealed refrigerant systems. Misconceptions about visual aspects can mislead students. Question 10. During the process of inspecting a brazed joint on a 7/8 suction line, is Patel notices the filler metal appears uneven and pitted. What is the most likely cause of this defect? A. Proper heating and rapid capillary fill. B. Torch flame too far from the joint. C. Contaminants or moisture on base metal prior to brazing. D. Use of high silver alloy in vertical joint. Answer. Correct answer. C. Explanation. Pitting and poor surface finish typically result from improper surface preparation, such as residual oil oxidation or moisture, which interferes with filler flow. Wars B.2 outlines that surfaces must be clean and dry to ensure wetting and bonding. High silver alloy or joint orientation are less likely to produce pitting if other factors are correct. Distant flame may slow heating but doesn't cause the described defect. Contaminants can cause porosity, voids, and weak joints, leading to eventual failure. Question 11. The conventional wisdom about torch selection suggests that for joining small diameter copper tubing under 1 which of the following torch systems provides the most efficient balance of portability, safety, and flame control in residential installations? A. Oxyacetylene with neutral flame. B. Propane torch with adjustable flame tip. C. Acetylene torch with medium flame tip. D. Oxyhydrogen with high velocity tip. Answer. Correct answer. C. Explanation. Acetylene torches are preferred for small diameter residential copper because they are portable, easier to control, and pose a lower overheating risk than oxyacetylene setups. According to says an industry field practice, they provide adequate ETU output for quick heating without requiring oxygen cylinders. Propane lacks the focused heat intensity and may take longer. Oxyhydrogen and oxyacetylene are better suited for larger joints or industrial settings. Overheating thin tubing may cause annealing or damage. Question 12. Taking into account brazing best practices, what is the most significant consequence of failing to clean and degrease copper fittings before applying flux and heating? A. The filler metal will bead and not bond, causing joint failure. B. The flux will prevent oxidation, so cleaning is unnecessary. C. The joint will overheat due to contamination absorbing excess heat. D. Aesthetically, the joint will appear discolored but still function correctly. Answer. Correct answer. A. Explanation. Contaminants such as oils, oxides, and dirt interfere with the wetting process, preventing capillary action and filler metal bonding. Or C.3 and HVACR brazing guidelines emphasize surface prep as essential. Flux can't clean heavy contaminants. It's designed to prevent oxidation during heat, not to remove grease or dirt. Joint overheating may occur due to prolonged attempts to correct poor flow, but the root cause remains surface contamination. Poor bonding leads to leaks, vibration fatigue, and system failure. Question 13. When analyzing high-pressure refrigerant systems like R400 TINA, which factor most influences filler metal selection for brazing copper-to-copper connections? A. Color consistency of filler with copper pipe. B. Alloy cost and availability in the local market. C. Compatibility with system pressures and thermal expansion. D. Electrical conductivity of the filler metal. Answer. Correct answer. C. Explanation. High-pressure systems demand filler metals that can withstand mechanical and thermal stresses. Also, 0.8 standards specify alloys like B-Cut5, 15% silver for enhanced strength and ductility. Electrical conductivity is irrelevant in refrigerant circuits. Cost may be a factor but cannot override safety and code compliance. Color matching is purely cosmetic and has no impact on performance. Students must associate filler choice with service conditions, including pressure cycles and thermal expansion. Question 14. Throughout the course of brazing dissimilar metals, such as copper and stainless steel, which heat-related consideration is most critical to ensuring joint integrity? A. Heating the copper more aggressively due to its higher resistance to heat. B. Applying filler directly to both metals before heating. C. Balancing thermal conductivity and adjusting torch technique to ensure uniform temperature at the joint. D. Using a fluxless brazing technique to maintain metallurgical integrity. Answer. Correct answer. C. Explanation. Copper conducts heat rapidly while stainless steel heats slowly, which creates challenges in achieving simultaneous joint temperature, as ORS and HVACR guidelines recommend. Torch technique must be adjusted to apply more heat to the stainless side. Applying filler before heating can lead to premature melting and poor wetting. Fluxless brazing is inappropriate for stainless and leads to oxidation. Proper distribution ensures the filler flows properly and forms a metallurgical bond on both metals. Question 15. When presented with a horizontal brazed joint on a suction line that repeatedly fails under pressure testing, which inspection clue most strongly indicates poor wetting as the root cause? A. Filler metal appears evenly distributed and smooth on the exterior. B. A visible gap appears where the filler should have flowed. C. A consistent silver sheen is visible throughout the joint. D. The flux residue is clean and easily removed. Answer. Correct answer. B. Explanation. Voids or gaps indicate that the filler did not fully wet and bond with both surfaces, a sign of poor heat control, incorrect joint clearance, or contamination. Was B.2 meters explains that proper wetting produces a continuous fillet with no gaps or holes. Visual smoothness does not guarantee internal bonding. Flux removal does not confirm penetration. A silver sheen may occur even when the internal joint lacks structural strength. Students must link visual inspection to metallurgical performance. Question 16. As demonstrated by Islo during a service call on a rooftop unit, what torch technique should be used to prevent filler metal from dripping or pooling while performing an overhead braze? A. Increase heat intensity to complete the joint faster. B. Use a quick fill technique by preloading filler metal in the joint. C. Reduce torch angle and use small amounts of filler progressively. D. Apply flux at double concentration to stabilize the filler metal. Answer. Correct answer. C. Explanation. Overhead brazing requires precise control to prevent gravity from drawing filler metal away from the joint. By using a low torch angle and controlled filler feed, the technician allows the metal to solidify in place via capillary action. ORS procedures emphasize progressive application to control flow direction. Increasing heat can cause burn through. Preloading filler is ineffective and can cause internal blockages. Flux concentration doesn't control metal movement. Technique does. Question 17. Based on the information in modern purging procedures, which method ensures the most effective internal oxidation prevention when brazing closed refrigerant piping? A. Introduce nitrogen intermittently during filler application. B. Flow nitrogen continuously at low pressure from one end of the pipe to the other. C. Pressurize the line with nitrogen before applying heat. D. Fill the pipe entirely with nitrogen and seal it before brazing. Answer. Correct answer. B. Explanation. Continuous nitrogen flow displaces oxygen and prevents oxidation inside the pipe during brazing. Says an HRConquer guideline stress a low, steady flow 1.5 SFH to maintain positive pressure without interfering with capillary action. Pressurizing beforehand or sealing creates dangerous conditions due to expanding gases. Intermittent flow is ineffective. Purging is required to prevent scale formation that can obstruct refrigerant flow and damage components. Question 18. To what degree does joint clearance influence the strength and reliability of a braze connection in HVAC systems operating under thermal cycling? A. It has no effect as long as filler metal is present. B. It should be as wide as possible to allow more filler. C. It must be optimized for capillary action and thermal expansion. D. It is only critical in high temperature applications. Answer. Correct answer. C. Explanation. Proper joint clearance ensures capillary action and accounts for differential thermal expansion during operation. According to ORS standards, the ideal clearance for copper joints is 0.002, 0.5 inches. Too wide gap results in weak joints due to poor capillary fill. It too narrow limits filler penetration. The mechanical and thermal stress of HVAC systems requires joint flexibility and metallurgical soundness. The misconception that more filler equals stronger joint is incorrect. Question 19. Under the assumption that a braced joint on a suction line exhibits leakage shortly after startup, what is the most appropriate corrective action for the technician? A. Apply additional filler metal around the visible area to seal the leak. B. Use epoxy or sealant to temporarily block the leak. C. Disassemble and rebraze the joint after cleaning and inspection. D. Drill a weep hole to relieve pressure and reduce leakage. Answer. Correct answer. C. Explanation. Leaking joints must be completely redone. Epoxies and filler overlays are not permanent solutions and are non-compliant. ORS and EPA guidelines prohibit patching refrigerant leaks with non-mechanical means. The joint must be disassembled, cleaned of oxidation and residue, and rebrazed with proper heat and filler flow. Leak indicates poor bonding or contamination. Drilling holes is dangerous and unacceptable in pressurized systems. Students must demonstrate long-term thinking, not temporary fixes. Question 20. Examining the consequences of joining copper tubing to an aluminum evaporator coil, what is the biggest metallurgical challenge the technician must overcome during brazing? A. Preventing melting of the copper at a high temperature. B. Managing differential expansion rates and galvanic corrosion. C. Ensuring filler metal matches both metals in color. D. Avoiding absorption of nitrogen into aluminum during heating. Answer. Correct answer. B. Explanation. Copper and aluminum differ in thermal expansion and electrochemical potential, leading to mechanical stress and galvanic corrosion. Special brazing alloys and fluxes, such as the N-based fillers, are required, as well as sealants and dielectric protection. ORS and NATE guidelines highlight that without proper technique and material compatibility, the joint will fail under pressure or corrode rapidly. Color match is irrelevant. Nitrogen absorption is not a brazing concern. This question requires understanding cross-material compatibility. Question 21. The most significant aspect of brazing steel to copper in HVAC service is understanding how different heat capacities affect the process. What is the most appropriate torch technique for Castillo when joining these two metals? A. Apply heat equally to both metals to avoid warping. B. Focus heat primarily on the copper side since it cools faster. C. Direct more heat onto the steel side to compensate for lower thermal conductivity. D. Start heating from the filler metal to balance both metals' temperatures. Answer. Correct answer. C. Explanation. Steel has lower thermal conductivity compared to copper, meaning it heats more slowly. ORS guidelines C.3 and field experience dictate that the torch should linger longer on the steel to bring both materials to brazing temperature simultaneously. Equal heating doesn't account for conductivity differences, and preheating the copper could result in overheating. Heating the filler directly violates proper technique and inhibits capillary action. Understanding thermal behavior is critical when joining dissimilar metals. Question 22. While examining the service history of ERST, Mr. Nolan identifies several joints that failed under pressure. Which practice is most likely responsible for these failures in a high-pressure refrigerant system? A. Using a flux with a melting point too low. B. Brazing without nitrogen purge. C. Selecting a filler alloy with inadequate tensile strength. D. Over-tightening mechanical fittings during pre-braze assembly. Answer. Correct answer. C. Explanation. In high-pressure systems like R400 TINA, filler metals must meet minimum tensile strength requirements. ORS 0.8 designates suitable alloys such as BAC5 or B-Cup5. For these applications, alloys with insufficient strength may fail under cyclic pressure. Nitrogen purging prevents oxidation but does not directly affect joint strength. Flux melting point affects flow but not pressure resistance. Over-tightening fittings could distort joints, but tensile mismatch is the most common root cause in high-pressure failures. Question 23. According to recent studies, which factor most critically determines the effectiveness of flux during the brazing of copper brass joints? A. The quantity of flux applied to the filler rod. B. The duration of time between flux application and heat exposure. C. The uniformity and completeness of flux coverage on joint surfaces. D. The color of the flux after heating begins. Answer. Correct answer. C. Explanation. Flux prevents oxidation and facilitates wetting during brazing. For full protection, it must be applied uniformly to all mating surfaces, not just to the filler rod. Or C.3 meters notes that partial or uneven coverage leads to oxidation in exposed areas, resulting in poor bonding. The time between application and heating matters less and less excessive. Color changes signal flux activation but do not ensure effectiveness alone. Correct coverage ensures reliable and clean joint. Question 24. With respect to tubing preparation, what is the primary reason for deburring after cutting copper refrigerant lines prior to brazing? A. To prevent corrosion from sharp metal edges. B. To avoid noise caused by turbulence in the system. C. To ensure proper internal refrigerant flow and prevent metal shaving contamination. D. To allow more filler metal to enter the joint. Answer. Correct answer. C. Explanation. Burrs left inside tubing can break off and circulate through the refrigerant system, damaging components like ESVS and compressors. HRCs and manufacturer guidelines emphasize internal cleanliness. Deburring also allows unrestricted refrigerant flow. Corrosion prevention and turbulence are secondary issues. Deburring does not improve filler metal flow. It protects system integrity. This question underscores the connection between brazing prep and long-term system reliability. Question 25. From a practical standpoint, what must a technician verify immediately after completing a nitrogen pressure test of a braze system? A. That the nitrogen was purged at full tank pressure. B. That pressure remains stable over time, confirming no leaks. C. That the filler metal is still visually intact. D. That the system is recharged immediately after the test. Answer. Correct answer. B. Explanation. A successful pressure test requires stable pressure over a defined period, usually 1530 minutes for standard systems. This confirms the integrity of all joints. ASHRAE and EPA service guidelines require this as diagnostic step. Full tank pressure is excessive and may damage components. Visual filler appearance doesn't confirm internal joint sealing. Recharging without confirming leak-free conditions is major procedural error. Question 26. To determine whether ISTA LUTs can use traditional copper phosphorus filler rod-on a copper to aluminum connection in a heat exchanger, what is the correct technical guidance? A. It is acceptable only if nitrogen purge is used during brazing. B. Copper phosphorus filler is compatible with all non-ferrous metals. C. A zinc-based or aluminum-compatible brazing rod must be used instead. D. The connection must be mechanically joined rather than brazed. Answer. Correct answer. C. Explanation. Copper phosphorus fillers e.g. B-Cup2 are not suitable for aluminum as they won't form proper metallurgical bond and may cause galvanic corrosion. Special zinc-based or aluminum brazing rods with compatible flux are required. Ors Innate recommend alloys specifically formulated for aluminum. Nitrogen purging doesn't change metallurgical compatibility. Mechanical joining may be possible but isn't required if appropriate filler is used. Selecting filler based on base metal compatibility is crucial. Question 27. A key distinction between neutral and carburizing flame settings on an oxyacetylene torch is their effect on base metals. What is the appropriate flame setting for brazing HVAC copper lines, and why A. Carburizing flame to prevent oxidation of the joint, B. Neutral flame to avoid metal contamination and ensure even heating, C. Oxidizing flame to help flux activate faster, D. Pulse flame to balance heat and gas pressure. Answer. Correct answer. B. Explanation. A neutral flame with a balanced oxygen-acetylene ratio provides clean, controlled heating without introducing excess carbon or oxygen. Or C.3 and torch manufacturer guidance warn that carburizing flames can cause carbon deposits, while oxidizing flames can degrade metal surfaces. Pulse flame is not a recognized setting in torch use. For copper brazing, neutral flames ensure proper joint heating and metallurgical integrity. Question 20. When faced with frequent service callbacks due to leaking joints, what diagnostic finding would most clearly indicate the presence of voids within a brazed connection? A. Intermittent refrigerant loss detected via electronic leak detector. B. Brown discoloration near the joint after operation. C. Consistent undercharging of the system post-repair. D. A hissing sound at the joint under pressure. Answer. Correct answer. A. Explanation. Voids allow refrigerant to slowly escape, often undetected until performance is impacted. Electronic leak detection at the joint area pinpoints leak paths. Brown discoloration may result from overheating, not voids. Undercharging is a symptom, not a diagnostic tool. Audible hissing usually indicates large, open leaks rather than microvoids. Proper brazing eliminates internal air pockets and ensures structural sealing under pressure. Question 29. When faced with brazing near a sensitive valve assembly, what best practice should be applied to protect the internal components from heat damage? A. Complete the brazing quickly to minimize heat transfer. B. Pack the valve with wet rags or heat-absorbing paste. C. Avoid using flux in that section. D. Lower the pressure in the valve before brazing. Answer. Correct answer. B. Explanation. Heat sinks, wet rags, commercial, paste. Absorb excess heat and prevent thermal migration to sensitive parts like Teflon seals or rubber O-rings. Also, OEA guidelines recommend this for valves, compressors, and sensors. Quick brazing may still allow thermal transfer. Avoiding flux impairs brazing quality. Lowering pressure has no effect on heat conduction. Using protective materials is a key technique when brazing near vulnerable components. Question 30. The correlation between filler metal behavior and joint temperature helps define the difference between soldering and brazing. What characteristic most clearly distinguishes the two processes? A. Soldering uses flux, while brazing does not. B. Brazing requires filler metals with melting points above 800 Fortideg. C. Soldering joints are stronger than brazed joints. D. Brazing is only used on copper, not steel or aluminum. Answer. Correct answer. B. Explanation. Poor's definitions. Brazing involves filler metals that melt above 800 Fortideg, 400 Fifthideg, but below the melting point of base metals. Soldering uses lower melting fillers. Both may use flux depending on materials. Brazed joints are typically stronger than soldered ones. Brazing is applicable to many metals, including copper, brass, steel, and aluminum. This question tests foundational knowledge required to distinguish processes by their thermal and mechanical properties.